This work we present learning by planning, language-guided global image editing. Given an input image and a language editing request, the goal is to edit the image following the request. The only supervision is the target image. The global here means the editing is applied to the whole image, such as global retouching. The GAN-based methods can tackle this task. However, the GAN has resolution limitation, and it is a black box model which is not interpretable. On the contrary, our model uses predefined operations and do sequential editing. We firstly create an operation list and then apply this operation step by step until the end action. Then we output the final image. In this case, we can preserve the resolution because the operations are resolution independent and also make the editing interpretable. Our method has challenged that no intermediate operation supervision is provided, so we have solution in two steps. First, we proposed operation planning to get intermediate operation supervision from input and target images. Then we use the intermediate operations and the target image to train the editing model supervisedly. Operation planning is a greedy-based algorithm. For the first action, we enumerate over all operations, take the brightness, we optimize its parameter alpha to minimize its L1 distance towards the target image, and its result is saved on the right-hand side. The same process will go through the rest of operations. Then we will select the action with the minimum L1 distance, which is the contrast as our first action. We move to the next step, enumerate over all operations again, and find the best one. We stop if the L1 is less than epsilon or stop at the maximum step n. Given target and input image, we show the planning sequence on the right-hand side. We can see that L1 distance to the target image is decreasing monotonically. And in the step 2, we train our editing model T2O-net. Here is the pipeline of the T2O-net, where we apply the T2O cell recurrently to generate the intermediate actions and images. We train our model with the plan operation and supervision. And here is the editing result of our T2O-net. Colorize the photo. Increase the brightness a lot, make it more colorful. Sharpen the entire image. Here comes more editing result. And then we compare with other methods. Remove the fuzziness and make the color more vibrant. Improve the color balance. Change the including outline. There are more advantages of T2O-net. First is resolution independent. Second, it can generate multiple possible outputs at the inference stage. First, it is resolution independent. Here we compare to GAN-based method. The zoom-in view shows that our method can keep the resolution of the input image. Another advantage is that we can generate multiple possible outputs in inference time. Here we show 3 edits, which use different sampled parameters at the inference. Next, we show 2 extensions of operation planning. First is planning with a discriminator. This planning result does not depend on target image, only use the operation planning algorithm to maximize the quality score of the discriminator. With this setting, the planning algorithm can directly edit the new images. Second is planning on local editing. We can see that our planned recovered output can recover the target image by removing some distractive person, by adding a segmentation model to get the object masks and add the operation in painting. Thanks for watching. Please see more details in our paper.